and check that perform certain checks in the source code, those checks may not be preserved by the compiler, right? Because compilers, the most important thing they do, in addition to trying to generate correct code, is to generate efficient code, right? And the way they get efficiency is by doing optimizations, right? And the most important type of optimization is to detect parts of the code that are not necessary for producing the intended output of the program and removing out that code. Okay? So, for instance, if you have so think of this type of let's see. Yeah, I'm trying to construct. Okay, so let me do this simple thing, right? Right. So this is sort of a some kind of code that you may have, and you can see that in this case, okay, it's n is positive because it's unsigned, and it's your typical integer overflow type of situation where there is a possibility that this 4 times n might wrap around, and the result may actually be less than n because of the wraparound. Yeah. Yeah. Unsigned means 0 and above. So the compiler might look at this and then say, of course, if x is greater than n, right, then it's going to conclude that this statement makes x greater than n, and therefore it doesn't have to check for this condition. So it might eliminate this check, right? So, but you can imagine that if there is some kind of an attack that relies on integer overflow, then it is possible that there could be a overflow there, and therefore the condition may not be satisfied. Right? So the point is that the compiler makes optimizations assuming that input is not under the control of the attacker. Right? This is sort of the model under which the compiler operates, and therefore it may remove checks that make sense only in the context of this kind of adversarial input, right? And then you can also imagine that, okay, what happens if the compiler tries to add a canary to your program, okay, to try to put a canary on the stack. Its optimizer will tell it this canary will never be overwritten because, well, because the compiler doesn't think buffer overflows are possible, right? So the again, the model is a somewhat optimistic model, one that works when your code is not under the control of when none of the data is under the control of the attacker. Right? So as a result, one of the problems with adding security instrumentation at the source code level is that the compiler may basically throw it out. Okay, so again, that might be another reason why you might want to put that check into the binary. Okay, so but security is not the only reason why you might want to do binary instrumentation. Sometimes you do that for, say, debugging, right? So I mentioned